Yes, we can hear you.
Okay, thank you. Just a moment. Um, just a moment. Um, oh. Okay. Mm. Now I changed the to the outside macro. So I would like to ask you again. Do you see the screen? That's the first page, decision making. And you hear me? My voice? Hello.
Yes, we can see the slide and we can hear you.
Okay. Thank you. Um, let's see. I just check in the Edisoft and I see our class now. It's about 43 or some like the students, and that's good. It's a bit crowded, 43, but it's still okay. Do you got the slides, the lecture notes of the chapter 2 here in the internet, in the Blackboard? You see these slides, the file in the Blackboard, and you download it? Hello?
Yes, already.
Okay. Okay, so that's perfect. Everything is okay. Today's February 16. Okay, we can start our class today. Here, we now start the chapter 2. That's our course is first chapter on decision making, so decision analysis, and the material is here. The material is on the book number 1. I tell you there at the first class, and it's here. Okay, I picked some content important to write out things in this, and other things you can read it as extra material, and of course you can find out. You can type in the internet, okay, decision analysis, then you can find some other material. So in this section, you have mainly this section chapter. We have 3 sections. This decision making, okay, under certainty. Another thing is under risk, and another is under uncertainty. So 3. That means we will consider the way, the method to make a decision in 3 different circumstances. First, under certainty, everything is clear, okay? Another thing is under risk. Something is not quite clear, but there is some probability distribution. For example, today, this afternoon, it may be rain, but you don't know if it's rain or not, but it's about 60% it will rain this afternoon, for example, 60% a probability of this, okay? Another thing is decision making under uncertainty. Nothing is clear. Don't know if it rains or not. You don't know, and you don't know either the probability for this. So the situation is rather hard, okay, to make a decision in the situation that everything is not clear. Okay. So what does it mean, decision analysis? Decision analysis, as you see in the slides, I write down something. Decision analysis involves the use of a rational process. Rational process means the process with reasoning, the process with the argument, with something to argue, to think, to judging, something like this. 4, selecting. In order to select, there is several alternatives, 1, 2, 3, 4 cases, and then you need to make a decision to choose one of the 4. Is that okay? To choose the best one in the best is not the optimal. you study the optimization one is already, but the best here is not does not mean that is optimal. The best in some point of view. If you look at this point of view, that is the best. You choose this one. But if you look at another point of view, maybe the other will be the best, and you will choose the other one. You will see it. The goodness here, the goodness of a selected decision depends on the data used in describing decision-making situation. If you use some situation is not some data, not good data, then you can the data will lead you to make some decision which is not good. Okay, so the best here means does not mean optimal like you have in linear programming. I don't know if you study optimization 1 already. Trần Hoàng Duy, can you answer me? You study optimization 1 with Professor Hai already? Of this semester? Hello?
Yes. Yes.
Yes, you already study last semester or just study this semester?
Optimization
This
one.
one.
Yeah. This semester. This semester stuff.
This semester. Yeah, maybe. Okay. You can study optimization one parallel with this. Okay, with this kind of decision making, and you will see that in optimization one, the best solution is the optimal solution. Optimal solution is the best solution. For example, you find some way, and so that you have the profit is maximum. So that means that way you get profit. If you do this way, you get the profit is maximum, and you speakest one here. And if you use another one, never get this one. It can be like this. It can be like this. No one can be higher. The profit can be higher than this method, this way. So this is called optimal. The best, really best. But in our case, decision analysis, best means best, but but not the maximum. If you look at this way, this is best. If you look in another way, this is best, not this one. Okay, so here there are some words to explain clearly what is the goodness. The goodness in the best. The goodness here of a select decision depends on the data you use in the process of analysis to make a decision. Okay, some situation where a decision making is needed. Some situations where a decision making is needed. That means when the question is when will we need a decision making. Decision making, that means making a decision. Okay, in which case you need to make a decision. Many cases in our life, many cases you need to make a decision. Is that okay? For example, in the last holidays, the 10 holidays of Vietnam, you move back to your family. Okay, and now it's time the semester has started, but the university tells you that the first 3 weeks you study online, and the week number 4, that means starting from the 1st of March, you will go to the university. So you need to then it raises up to you. You are at at your family, and you need to make a decision. When will we come back? When we come back to Ho Chi Minh City? Okay, something like this. That is the case that we need to make a decision. And in that case, you see that it depends on a lot of things. Is that okay? Somebody you will stay here and you have okay, the dormitory, and the dormitory is still closed until today, so I cannot come here. And next week the dormitory of the VNU will open, and you need to make a decision. That means next week you will go there. And somebody else come here to stay with the friends or something like this. So you see, the best decision for you is best in the situation of yourself. Is that okay? Best in that way. It's not the best as the best in optimization. No, that's. You can go. You can come to this week. You can come to Ho Chi Minh City next week, but somebody can come the last week or something like this. It is you need to make a decision, but that decision will be best for you. Okay. In many cases, you will need to make a decision, like in the transportation problem, you network flow problem. These things on this topics you will learn if you continue studying optimization too. You have some problem in, for example, in linear programming, like you study in optimization 1. But okay, to the decision to produce how many products of this kind, how many products of the other kind, or something like that, so that the benefit, the profit you get is the best. Okay. And these are the case that you can make a decision, but with certainty. Okay. The situation, for example, the situation in a factory. You want to make profit is the best, the optimal, the maximum profit, for example, then everything is clear. You produce, for example, the profit, the company that want to produce a pen, for example, like this, a pen, how many workers there is certain. The company have 100 workers. They have 5 machines. They have 4 warehouse, and everything is certain. Everything is fixed. Is that okay? It's okay. And so in that case, they have to decide how many pens, for example, like this, for a week they need to prepare to produce. How many, for example, they also produce the small calculator like this. Then they need to decide how many pens, how many calculators have produced in 1 week, so that the profit they receive is the highest, maximum. Is that okay? And in that case, you need to make a decision, and everything is fixed. The condition is fixed there. And so in that case, we have the decision making with certainty. That is the first situation. Another situation where your decision will be made, but we say decision making at a risk. Look at here. Decision making at a risk. An example is this. A manufacturer means a factory, okay, company, introduce a new product into the marketplace. What will be the reaction? What will be the reaction of potential customers? The customers potential, that means when you produce this one, then you can think of students at high school, that okay. Students at university, we use it the most. Teacher, not necessary. That okay. A worker, an officer at, for example, at my university, IU, for example, not much. They don't need this one, but students certainly. So students at high school, students at secondary school, students at university are potential customers. Okay, but when we produce a new kind of this, so what will be the reaction of the potential customer? What? How much should be produced? How many items should be produced? Should the product be test market in the small region before deciding upon a full distribution? Should we test in the small market before make it with a large amount and distribute at the same time everywhere. How much advertising is needed to launch the new product successfully? So if you see, normally people often make advertisement. You see advertisement in the television or something like this. People have to calculate. Is that okay? How much advertising is needed? How much money is spent for the advertisement for the new product? Something like this. Data only got by inspection. Credit based on the last experience, the experience in the past, or something like this, and the data you get often give by some probability distribution. In the past, you will make an inspection in the past. Normally, we when we introduce a new product, then the welcome of the potential customer should be 60%, 70%, or something like this. So in the case you can get some data from the experience, from the real situation in the past, and the data you get in some sense, in some form, like probability distribution, something like this, and you make a decision based on this thing. And in that case, we say that we have the case of making decision under risk. Okay. Another thing is making decision under uncertainty. So what is the case under uncertainty? For example, we will consider this later, but first of all, it's very simple. An oil company deciding whether to drill for oil in a particular location. For example, the company buy a piece of land, and then they decided to drill for oil. You do not see in Vietnam, but you go to USA. You go to USA. You go to California, Texas, and then you will see. And you also can see in the television. You see something like the machine that's just like this. That is they pump the oil that are going in the well, but the well is in the land, not in the sea like in Vietnam. In Vietnam, they drill for oil in the far sea. Is that okay? Like this, but in many other ways in the what you say in Kuwait and some country in the Far East, the Middle East, and also in USA, like I tell you, in California, in Texas, you see they drill for oil in the land. Okay, not in the sea. And so around there, 1 kilometer far from here, they can drill for oil. So the company buy this land, and then they hope that they also can drill for oil in this land. Okay, so but how likely are there? How likely is oil there? There is oil there or not in this land? How much and how deep we have to drill? How deep to drill to get oil? Should, and the answer is, should geologists investigate the site further before drilling? That a lot of information we don't know. That okay? We don't have the answer for this question, and even the question that should we pay money for some we say geologists That means that some expert come here to make an research, to make an investigation, and to see that we should real or not something. So in this case, you see that in the case we don't have any information. That's a lot. Everything is the risk there. The situation we have the manufacturer or producer, we will still have some data. Even the data is not quite sure. The data may be the welcome of the new product from the potential customer in the past is about 60% or something like this. But even it's not quite sure, but you still have something, 60%, more than 50, that is okay. But here, this situation is quite hard. We don't have anything, data, even probability of some assertion if there is I or not or something like this, and we have to read very deep to get oil or just some 200 meter and then you get oil. No, we don't have any information. But anyway, this is the case that we need to make a decision. For example, the boss of the company, some company, need to make a decision. In that case, we say we need to. This is the situation of decision making under uncertainty. So I tell you very roughly the situation of the three situations. Okay, where decision making is needed. The first one is the decision with uncertainty, with certainty. The second one, making decision under risk. The last one, making the decision under uncertainty. So we will go, as you see here, we will go to the three sections concretely. Is that okay? Each section is one of the situations where we need to make a decision. Okay, and today I hope that we will finish all the three cases here. Okay. There are these are means the case, the last case you have here. These are the kind of decision making in the face of uncertainty that decision analysis is designed to address. The method called decision making under uncertainty is a way create for this case. Is that okay? For have you to have the good decision, good the good decision in such a case. We will just shortly, we have three categories of decision making process: decision making under certainty, decision making under risk, and decision making under uncertainty. So three categories of decision making, and we will go to each of them. The first one is decision making under certainty. Okay. This case, the method, the way we use is called analytic hierarchy process. So, the name is a bit hard to pronounce, and so we say ASP way method. So briefly, some words on this. Decision-making uncertainty include the situation that can be described as a linear programming. Linear programming, and this you will study with Professor in optimization 1. So linear programming is a problem. You study Zhang Huang Yui, you study the optimization 1, you study linear programming, the first chapter or not? Linear programming?
No, teacher.
No, not yet. So I tell you like this. The linear programming is this. Just a moment. The linear programming is I don't know. I moved to another slide, but in your what do you see in it? What you see in your computer? The page with the first section introduction. Or you see
a draft paper?
the draft paper. Okay. So that means that my computer here is not good. Okay, the draft paper. So you see the linear programming. Linear programming problem is a problem like this. Find out the infimum of sigma C1x1 CIXI I1 to n, and then AX less than B, and then X greater than 0. X is equal to X equal to something like this: x1, x2, xn. This is belong to Rn. Is that okay? And A is matrix. A is matrix is m by n. Aij m by n. Is that okay? And A here, A is matrix like this. And this multiplied by x1, xn, and less than here is you have b1, bn, something like this. So the problem like this is called the LP, that's the linear programming. Find x such that this function with CI is given attain the minimum. Find x bar, the solution such that among all the x satisfied this condition, okay, so that it make this sum become the minimum, and that is the solution. Is that okay? And in the solution of this is you make a decision that to find x bar so that this is attain the minimum, and this is a decision making problem. You find x bar. Is that okay? But this is everything here is fixed, certain. Okay, certain. A is a matrix and no change. C1 is 1, C2 is 2, or something like this. Everything is, and that is one of the, when you study the optimization 1, you see linear programming is one case that you can make a decision, and that's a decision with certainty. Let me check. I don't know why. In my computer, it is still introduction. It have not yet changed. Cannot change. So it's funny. Oh my God. What do you see in your screen? A 2.1 AHP via prototype example, is that right?
Yes,
Yes.
sir.
Okay, but in my computer it doesn't work. I don't know why. I don't know what it says. Doesn't change. You wait a minute. Because in this way I cannot follow that you can get what you get in your screen. Normally I make things in the iPad, and what you see in your screen is exactly the thing I see in my screen. But now my screen is fixed, it doesn't change, it do not run in. So you wait a minute. I will start again to share the screen again to see what happened. No, it's funny. Just a moment. Hello? The AHP via prototype example. You see it?
Yes, sir.
Okay. So prototype is typical. A typical example. Now, for this case, is a problem that I tell you last week. Okay. I use this to make an introduction to the decision making. But now we study it again, and I just want to repeat it. Okay, to have a repetition so that you can understand this example clearly. So now we listen again. The situation is that Martin Hans is a student. Okay, just graduate from high school, who is a bright high school student, and he has received full academic scholarship from the three institutions, three university. University A, University of B, University of C. You see, UA, UB, UC. He got all the three university. He got full fellowship for studying the undergraduate. So to select one, but he, of course, he cannot study at the same time three university. Even he like that, but impossible. No one can study at the same time three university. So he need to choose one university. Okay. For example, some of you maybe you already got this situation in the entering university examination. You may got the you may have a permission to go to IU, permission to go to the natural science university, and maybe University of Banking or something like this. And in that case, we need to choose one of the three. Okay, so, but when you make a decision, you think of a lot of things. Okay, the reputation of the university, the distance from your university to your home to university is far. It's okay, the university in the Gò Vấp, and the way from the district 1 to Gò Vấp is always traffic jam every day and very hard or something. So that every elements that have a direct effects to your life, to the your study, have bring into consideration. Of course, in our life, a lot of things, but here we, in order to make things easy, we consider only Martin consider only two criteria. The first one is location. The second one is academic reputation. Why? Why academic reputation? Location is easy. Okay, it's if the university is near, if the way goes there by the highway, and he can drive a car to the university easily, just 5 or 10 minutes, then it's good. Okay, but the academic reputation is also very important. Why? Because if you go in you study, if you finish, if you graduate from university with the high rank, is that okay? Then you with the certificate of that, you can get a job easily. Many company want you. Is that okay? But you go in some university very level like this, and with the certificate up, with the degree, graduate from that university, maybe hard. Okay, and of course the second the two criteria, one location, another one is reputation. The two things in our mind is, we also calculate, also think of this thing, but you know the two criteria is not equally important. Some important than another. Okay, so you see that this academic reputation here is more important than location. In okay, of course, in some of you think that the location is important, but I think many people think that academic reputation is more important. For example, with the 10, and then you have here academic reputation is 8 points, and location 2 points, or something like this. Is that okay? So in that case, Martin judgment like this: academic reputation is 5 times as important as location. 5 times. 5 times is what? Suppose the sum is 6. The sum is 6, and location is just 1, and another thing is 5 times bigger. So that means that 5 among 6. 5 among 6 means 83%. Is that okay? 5 over 6. 1 over 6 is 17%. And so, by this way, the weight for the academic reputation with Martin is 83%. That means 0. For example, if it is equal to 0.83, and that is equal to 0.17, something like this. So the sum of the two is 1 point. Then academic reputation 0.83, another one 0.17. Is that okay? You understand the weight of the two, like this. And using a systematic analysis to be clarified later. Martin ranks the university as follows. He ranked the 3 university UA, UB, UC as follows. You know, everything is certain with the number. They use some method which is called the synthetic analysis, okay, to calculate. And he said for the university A, location 12.9 point, and reputation 54.5. That's very high. Reputation at this university very high, but the location is just 12.9. That means the position is maybe very far. Is that okay? Very far, like IU. Okay, in Thủ Đức, your stay in your home is in Ho Chi Minh City, but the university is very far. Another one, UB. Location is high. Okay, location is okay, 27.7, but the reputation is also so-so, 27. And the University of C, location is 59.4. Location is a very, very high point. Location is very suitable. It's very close to your house. You can use motorbike to go there in 5 minutes or something like this. In 59.4, but the reputation is just 18.2. So by the percent weight estimate for the 3 university on the 2 criteria, location and reputation, is this. And the question is, you see, if the data or calculation of Martin give him this table, and the question now is, with all of this number, what university should be the best for Martin, or what should he choose? Is that okay? Which one? UA, UB, UC. And the last time I remember that there is one student can answer this question, Nguyễn Thị Minh Thư, and I give him her 5 points already for this, because the reputation, the location in with Martin, the location is just 17%. 17% means 0.17. And the reputation is 83, 0.83. Is that okay? Like this. High point. For example, the UC. The location is very high, but the weight at the location is low. You see? The reputation is low, but the weight in, but it is the thing that Martin preferred a lot. And so in this case, how can we make a decision? You see? Of course, and when you learn it already, the method I teach you already, then you see that it's easy. But for example, now at the moment, if you don't have anything in your mind, and you don't have the method, so based on what? On these numbers, how can we choose the best university? I don't know if you still remember what I'm talking last time or not. Who can give back the answer? Which university, UA, UB, UC, should Martin choose? Which one? And why? You can raise up your hand and tell me. Hello? Just a moment. Okay, any of you still remember the last week? Which one Martin chose? And yes,
Can
who
I
is?
answer?
Yes.
Martin should to the University of A.
Sorry, what's your name?
My name is Cẩm Thanh.
Okay, Cẩm Thanh. Okay. So why? Why he should choose A?
Because when I calculate, I ý là lấy cái location 12.9 nhân cho cái quay của nó thầy, rồi cộng cho reputation 54.5 nhân cho cái quay của reputation thì mình ra một số, rồi tiếp tục mình làm với UB UC thì mình thấy cái UA nó có cái số lớn nhất nên là mình chọn.
Yeah, that's right. that is what we make in the last week. The reputation location is 12.9, but the weight of this is 0.7. So the average weight for A, average weight for University of A is 12.9. The location multiplied by 0.17. Is that okay? That is the weight of the location. And plus, the weight of the reputation is 54.5 multiplied by 0.83. And then you have what we call average weight of A. So you write down some number here. So you got some number here. The number is something here. Is that okay? Let me take the calculator, and then we calculate. We see 12.9 multiplied by 0.17 plus 54.5 multiplied by 83. Oh my god, multiplied by 0.83, but I type 83, so 83, so divided by 100, and then that's equal to, oh my god, what is it? Maybe not correct. It's something that is you know, that is that's the calculator of my son when he was about 10 class, and now it's about 30 years. Oh no, now it's about 20 years or something like this. So the screen is so dim I cannot see it. And then you will see UA, you calculate, and then you get this 0.4743. And the UB you calculate the same way, UC you calculate the same way. So the average weight, or we call the composite weight. The composite weight of A is this, and it's much higher than the other one. Okay, that means what is the composite weight? Composite weight means the weight, but it is a composition between location and reputation. Its location like this, the mark of location of this university is this, and the weight in his mind is 0.17. The mark of the reputation is this, and the weight in his mind is 0.83. And you sum up this thing, then you will see, you will have the composite weight is here. and you compute the composite weight of the three university, and you will see UA is the highest one. Okay, Cẩm Thanh, thank you, and you get 5 points bonus. Okay, and so that is one way. That is the way of calculating and the way for you to choose a decision, make a decision. Okay, and that is this problem is actually the problem of decision making. You know, you are facing three ways, and you need to choose only one. Okay, so you need. This is actually one situation where a decision making, or where you need to make a decision. Okay, and that's what we call decision making situation. And related to this, you have one more now related to this decision maker. The people who make a decision, we call decision maker. Decision maker. This is actually one way, one decision making situation. So UA is the best choice for Martin. Okay, but it is very simple. If we can draw this as in the scheme, or the figure, and then we say like this. The problem is here. Select a university. Is that okay? And there are two criteria. Two criteria. One is location, and another one is reputation. It is 17%. It is 83%. And they say here we have only one hierarchy one criteria. That is just one thing: location and reputation. And with the location, you have the three university: UA, UB, UC. Is that okay? 0. The mark is this. The mark is this. The mark is this. And with the reputation, 83%, and you also have a three university. Yes, and the mark corresponding three like this. And how to compute the we call the composite weight. A, with the University of A. University of A, you have a location, and reputation here. Just a moment. University of A here, you have the location, and you have a reputation here. You this, go to this. When you compute the composite weight of the University of A, you need two things, 2 points. One point of the location, 1 point of the reputation. But you need to combine with this. To combine with this one, combine with this. This one, combine with this. Is that okay? And then you get this thing. That is the composite weight of A. And by the same way, the reputation and location and reputation, you combine, you get of the B, the composite weight of the B and C. And you see, they compare the three numbers here. The biggest one will be the one best for you. It's okay. You understand? Do you have any question to ask me in this case? Hello? Hello? Maybe not. The last time we studied this already, and now it's easy. Okay. But the situation sometimes is not simple like this. We also have some analytic hierarchy ASP with several hierarchies, criteria. The first one there, the example there, just only have Martin. Is that okay? But now the situation become more and more complicated when you can imagine in the family have a two children, Martin and another one. Martin and there is Martin have a twin sister. Have a twin sister. So that means twin means here they want to create the situation that the two have the same class. Is that okay? The same level. This year, both of them graduate from university, and they are all bright. And Martin get the Martin get the full fellowship for the three university UA, UB, UC, but his twin sister is Jane also accepted, also got the full fellowship from the three mentioned university UA, UB, UC too. But if you know, the point of view of Jane and Martin are different. Martin say location is not important. Reputation is five times important than the location. But for Martin, for Jane, is girl. Maybe she does not think like this. For her, going to a very far place is also very she will get a lot of trouble. And so for that, for her, maybe the weight for the location and the reputation are not different from the Martin. Is that okay? So we continue reading. The structure of the new decision problem is summarized in the figure 2, in the next page. We look at the next page. Next page here. Change. The first one, hierarchy 1, hierarchy 2. You have the first thing. You have 2 for Martin. For Martin, you have here the left part. So it's the same like before. Is that okay? Martin think of the location here. His evaluate about the location and reputation. But Jane also have her own estimate on the importance of the location and the reputation. Maybe P1, P2 is belong to Martin, Q1, Q2 belong to Jane. But at the first hierarchy, Jane and Martin. For the parents want that the idea is this: we should choose a university. The father prefer that two children study in one university. This is better for them. Is that okay? They come to okay. They related to only one university. The best is that, and Jane and Martin need to find a way how to choose one university with the best for both. Is that okay? Only for Martin that University of A, but for Jane it may be different. We're calculating thing, but for the first hierarchy, you have here Martin and Jane. Martin and Jane, you have here PQ. What does it mean? It means that, for example, for the parents, they say the idea of Martin is they prefer the idea of Jane. Is that okay? Because Martin is a boy, so Jane is a girl, so things may be harder, maybe more difficult for her. So the idea of Jane 60%. The idea of Martin maybe 40%. You understand? The idea of they prefer, okay. The parents decided that, but in this case they don't want to distinguish this thing, and so in our case we can say that these two are the same. So we can consider here P is 50% and Q is also 50%, 0.5, 0.5. Okay, that is okay, but I mean that in this hierarchy, the weight may be different. Okay, the weight may be different. For example, in the two children here, there is one of them got some trouble with, for example, Jane got trouble with her eyes, so she cannot drive very far, and so the parents say, okay, I give Jane the weight 60%, the decision of Jane 60%. Is that okay? In that case, 60%, 40%, something like this. But okay, normally equally, 50-50. So how can you calculate in this case? How can you calculate for the weight, composite weight of the A? Composite weight of the A of the UA. UA, you calculate UA, location and reputation of A composite in this way. Is that okay? UA. And for Martin and for Jane, you do the same thing for Jane. For Jane, you also take the UA here, the location and the reputation, and location multiplied by Q2, this multiplied by Q1, and you know that for Martin, UA location here multiplied by P1, reputation multiplied by, you sum up all these things and sum up. But this the first one here multiplied by P, and the second one here multiplied by Q. Is that okay? And then sum up all here. The weight, the composite weight of Jane of Martin multiplied by the weight of Martin, P. The composite weight of Jane multiplied by the weight of Jane here, Q. And then you sum up and you compare. This is just one university of A. For university of B, for university of C, you do the same way. And you get the 3 number. This number is composite weight of both Jane and Martin, including the PQ, the weight of the idea, of Martin and Jane, PQ. Okay, sum of all this, and then you get. So by this one, you have the composite weight of A, B, C, and you compare this number, which one is the highest one, then that is good for both Martin and Jane. Is that okay? Okay. And here, the number P1, P2, opinion of Martin and the change rank P11, 12, 13. Here, look. P11, 12, 13. So that means that for the location of the tree, look at this. You look at this row for the location. You remember the points of the location, the tree. This is something like a percentage. You see, 12%. This percentage, and so the sum of this must be 100. You understand? 12.9, 27, and 4. Let me think. Is it right? Yes. The sum of this is 100. Okay. That you write now in points. But in this case, you write down in this way: 0, 0, 0. So the sum of this is 1. 1 means 100%. 100% is 1. You see? 83% means 0.83. Something like this. So the sum of this is 1. The sum of this is 1. Okay? The percentage of the location is 1. And so for the case here, you see the same thing here: P11, P12, P13. So all the P of the three university for the location is 1, and then it's 1. That is exactly what we write down here: P11, P12, P13, P1, Q11. Q is a reputation. P is about location. Okay, and P1 is the P1 here. The first P-I-J. So I here means I equal 1 means Martin, and here I equal 2 means Jane. Like this. So the two things here is 1 on the left is about Martin, the weight of Martin, right, the weight of Jane, and we calculate the composite weight. And here you see the P and the Q here. The P and the Q is the weight of the parents to Martin and Jane. As I tell you, the parents can say the opinion of Jane is more important than Martin, so 60%, 40%, and then we have to calculate here 40, 50. Is that okay? We calculate all of this, and then we have the composite weight, WA, WB, WC, and of course the biggest number. The university have the biggest composite weight should be the best for both. And we go to another one: decision making under risk. Okay, the second situation, decision making under risk. But maybe we should have a break. Is that okay? We have a break. 10 minutes. And now it's the time. I see that 14:33. So we go to 14:43. Okay. 10 minutes for a break. We have some cup of tea or something like this. So stop recording. So it's quite hard for you to calculate using the probability. Actually, in this this part, still you need to use some knowledge of the probability. That's the Bayes theorem. Bayes theorem. So some of you study probability. You know the probability, conditional probability. The probability of the event E under the condition A, or something like this. PE over A. And the Bayes theorem is on this. Okay, but that is 3.2. And now 3.1, we do not use it. And we study the theory via a typical example, okay? Example is it. Jack wants to invest $10,000 in the stock market by buying shares of one of the two companies. You know stock market, you know that word. Is that okay? Sure? Stock market. In the stock market, you have a stock share. Stock share of one company. Is that okay? The share. Share. You have stock market. Stock market, you know, sure for sure. Is that okay? And the share, one company, you have a share. So he want to invest. He have $10,000 here. He have $10,000, and he want to invest in the stock market by buying shares of some company. And there are two companies, the company A and the company B. Jack have got the information. Follow. Company A and company B, okay, and the information normally is come from the information, what he got, the information here, come from how you say, is some papers of internet, some company like consultant company or something like this. So the information he got is as follows. Share in company A, though risky, could yield 50% return on investment during the next year. If the stock market conditions are not favorable or bear, in the case of bear market, the stock may lose 20% of its value. That means that if the situation is a good market, then the return is very good, 50%. So if he invests $10,000 there, if the situation is good, he will get 50%. That means 5,000 more. So just at the end of the first year, he got $15,000. But that is the market is good. We call the bull market. Bull here. The bull market. That's the market is good. Then you get that one. But in the case of the market is bear, that means not good, then you may lose 20%. Lose 20% means that you invest $10,000, but at the end of the first year you lose $2,000, 20% too. So that means you still have $8,000. So two cases. If the market is bull, he will get $15,000. If the market is bear, he will get still have 8. 10, he put 10, but still get $8,000. Okay, that's the company A. That is the share of the company A. And now with the company B, provide safe investment with 15 return in bull market and only 5% in the bear market. So what does it mean? It means that if he used all the $10,000 to buy a share of the company B, and then if the situation is good, the market is good, then he get 15%. That means 10,000, he get 1,500. And so at the end of the first year, if the market is good, the bull, and then he get $11,500. But in the case the market is bear, still at 5%. So his money at the end of the first year is still $10,500. So it's still more than 10,000. That means he didn't lose anything. The first case, company A, in the worst case, the best, you will get $15,000, so a lot of money. But in the worst market, the bear market, you still have left 8,000 to lose 2,000. So company B, in the case good market, you get 11,500. But in the bear market, you still get 500. So that means your money is still $10,500. And the question is what? Which company A or B he should? Here is Jack. Jack should buy the share. Any of you have an idea? Which one is okay? The first one is a bit risk. Is that okay? If I don't know the next year, but if the market is boom, then he get a lot, 15,000, 10,000, 15,000, just in 1 year. But in the case was lose 2,000, still have 8. And the second one like this. So up to you. Which one you should invest? I asked some idea of Vũ Ngọc Khánh Linh. Khánh Linh, you tell me. Up to you. Which one is you should choose? If you have $10,000, so which one you should choose? Khánh Linh, you are still there? Hello? Hello, Khánh Linh, you are there?
I'm here.
Okay. You are not sleeping. That's good. Okay, what is your idea?
Not yet, teacher.
Okay, so somebody else, you want to tell me what your idea?
Can I answer, sir?
Yes, who is it? Nguyễn Thị. You are Nguyễn Thị what?
Minh Thư hả?
Minh Thư, okay. Nguyễn Thị Minh Thư, okay. So what's your idea?
I would choose company B because in both cases I will get the return even in the bear market. I also get a return instead of in company A.
Instead of losing $2,000. Okay.
Yes.
That is one point of view. So I tell you, decision making, sometimes we choose to get the best, but the best is not really the best. Is that okay? In the point of view, some people something very careful some careful people, of course, in this case, choose B is good. Is that okay? Safe. It's safe. But some people want to play the risk. They always want to play the risk. Okay, so of course, it means that we make a decision. In this case, we don't have any more investigation. You understand? We don't have any more investigation, and so the information we get just like this. If I don't know, next year, bull or bear. But if you are people who like to take the risk, that's okay. You choose A. That's okay. Either we get $5,000 or we lose 2. That's no problem. But by the way, here I just want to tell you, without experimentation. Without experimentation means that we base on the information we have here. You understand? But if you want to have some more experimentation, so means what? It means that okay, I will have $10,000, so now I will give $200 or $300 to pay for some company, and the company give some consultant company. He make the company will make in for you an investigation to see that okay. During the last 5 years, the tendency of the market. What is the tendency of the market? The tendency of the market is always boom, 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 like this. But nothing happens special. Nothing special like COVID. You see, if COVID-19 appear, then maybe boom become bear. But everything is okay. No, nothing happened. And then until the past 5 years, always boom, boom. Then I hope that the next one will be boom. That okay? And with some more money, make some more calculation, and the company gives us a predict next year is about 60% or 70%. Probability is 70% will be bull market. And then we have some more information to make a decision. Is that okay? And that is the case with experimentation. Now we say we are in the case of decision making without experimentation. So anyway, Nguyễn Thị Anh Thư, you say what? Anh Thư, you say that you choose B. Is that right?
Yes, sir.
Okay, that is one idea. That's one idea. We see that in the next page. And now something more. There's some more information. All the population publication check have consented are predicting that 60% chance for the bull market and 40% chance for the bear market. Okay. If you have some more information like this, then how can we choose? Many ways. Decision making theory give you some way to make a decision. Okay, it depends on you. We cannot say which way is the best, but which way is the best based on your point of view. Is that okay? Like I tell you, B is safe. B is safe. A is risky. But if you are successful, then you get just 1 year $5,000. That's a lot, but risky. B is safe. So if you are a very careful person, then you choose B. Some people like to take risk, then they choose A. For them, A is best. But for the careful people, B is the best. And so you see, it's not like a linear programming. It's not best means best, always best. Best means highest. No one can higher than it. But decision making different. But anyway, it still gives you the way. It gives you the way that if you are careful people, you choose this way. If you are people to take a risk, choose this way. If you are people that who want to calculate carefully before, then you use this way, for example. Look, there are several ways here. This is the table. This is a table where I summarize all the information here. The decision alternative. Decision alternative, you have two things, company A or company B, A or B. And the market, the situation of the market, you have seen bull market and bear market. So this is called state of nature, bull or bear. Well, state of nature. State of nature. That things will happen next year. Bull market or bear market. That is, and the decision you have to choose. The decision is here, A or B. You see, A or B. And the probability of occurrence. The probability of a current bull market 0.6, bear market 0.4. Okay, so all the data is summarized here. That okay? And now there are some way. I tell you some way. The way is here. Maximum payoff criterion. Maximum payoff criterion. This is one criterion based on the maximum payoff. Payoff means pay. Payoff is the payment at the end. Maximum payoff criterion means what? Maximum, you not maximum, you understand? Maximum is the maximum. Maximum, it means two things. We take the max and we take the min. We take the max, and among the max, we take the min. You know? So maximum. So each possible action, that means each possible alternative. For each possible alternative A or B, we find the minimum payoff over possible all the state of nature. We pay the minimum over in one alternative, company A, and over the all possible of the nature, bull or bear, you find out the mean of payoff, the mean payoff. So that means that if you look at here, stock A, in the bull market, the payoff is 5,000. In the bear, minus 2,000. So if you look at the row like this, from the bull to the bear, the mean, you take the mean. The mean is minus 2,000. And for the company B, the mean is 500. Is that okay? Row like this, during the state of nature, bull, bear, so you take the mean of both rows. And then with the mean like this, you take the max. Take the max. So the max is here. The max is here. Okay. So this is the way that Minh Thư does. You take the mean and you take the max. Very careful, people. you take the mean means what? You take the mean of the rows, means you consider the worst case. If you invest in the A, the worst case lose 2,000. If you invest company B, the worst case you get 500. And among the worst, you choose the best among the worst. You see? The two worst case, you had one case you lose 2,000, one case you get 500. So you choose the best among the worst. You see? So maximin, max C, max min, but people write out maximin to easy to read. Okay, max min or maximin, maximin. Then that means that you choose the mean first. Choose the mean first, and then you choose the max of the mean. The mean means what? The mean means the worst case. The worst case, in the worst case, that is the bear market. If you choose A, you lose 2,000. You choose B, you lose like this. So the best among the worst is 500 here. Is that okay? So it's something similar like Minh Thư choose. Are okay? Very careful, people. Okay, maximin. You remember, one method is maximin. You choose the mean of each alternative, and through each of the nature, state of natures here, state of nature here. Okay, you one alternative, you choose the minimum, the worst case, the worst case, the worst case, and then you look at all the worst case here, you choose the maximum. Is that okay? So the best of the worst, you can say like this: best among the worst. The best among the worst. Okay, so that is for careful people, the way for careful people. Okay. Maximum. And you choose, of course, you choose the alternative, give you the maximum here. So in this case, you choose here, the minimum here, this one, and the maximum here. So that means you choose by this way, using this method, you choose the company B. And what is the next way? Maximin payout. Okay, then like here, min. The min is here, this, and the max is here. I explain things, so it's here is the maximum. You understand? Maximum likelihood criterion. Maximum likelihood. You look at the maximum likelihood is this. The maximum likelihood. First of all, you look at the probability. Maximum likelihood, that means maximum likely happen. Is that okay? So 60%, this means that 60%, and here is 40%. So the maximum likelihood is here. Is that okay? So that means that the maximum likelihood is the bull market. Is that okay? So first of all, you choose the maximum likelihood, the bull market. Is that okay? And for the bull market, you choose the maximum between the two payout. 5,000, 150. Look. Maximum likelihood. Choose most likely state of nature. See, most likely the state of nature, that the mean with the loss, the one with the losses probability. So you have bull and bear. State of nature, you have two. In our example, we have two states of nature: bull market, bear market. And the most likelihood, that means the state of nature with the highest probability, 60%. So the bull market. Okay, for this stage of nature, choose the action with the maximum payout. Okay, look at this. Here. Here. You have a two, bull and bear. Okay. Two, you have two states of nature. 1, 2. And you choose the one with the highest probability. So you choose this one, 60%. And among so you choose the one, the state of nature with the highest probability. That means you choose the bull market. And for the bull market, you look at here. For the bull market, you look at the payoff. 5,100, 1,500. So which one is bigger? Of course, company A is bigger. You choose the max. And means that you choose here. Choose company A. Understand? Maximum likelihood. So that means, first of all, you choose the state of nature with the maximum probability. That is, in this case, bull market. And among the, and forget the bear market. Forget the bear market. Is that okay? Just look at the bull market. So the two alternatives, which one give you the payoff higher than the other? Maximum payoff. The maximum payoff here is company A. Is that okay? So if people like lottery, like people like playing game or something, he like probability. Okay, some people love probability. He may use this way. 60%. Okay, less than, greater than 40%. So the probability of this happen is high. The chance for this happen is high. And in that case, I choose this case. And in this case, A is very good. So I choose A. Understand? Hello? Hạ Uyên, you understand? Hello? Hạ Uyên? Are you sleeping? Hello?
Yes sir. Em dùng hai máy nên em phải kiểu bật mic máy bên này mới trả lời được thầy.
Yes, okay. But what I ask you is, you understand what I'm explaining here about the maximum likelihood criterion?
Yeah, roughly.
Maximum likelihood is very easy. That you choose the state of nature with the maximum likelihood. Maximum likelihood means the higher probability. So we have a two state of nature here, bull and bear. The bull is 60%, the bear is 40%. So which one is higher? Bull is higher, 60. So we look at only the bull market. If you look at the bull market, that means you believe that the bull market will happen next year. And if the bull market, then you compare the two companies, A and B, which one give you the payoff better? A, is that right? A give you 5,000, while B give you just 1,500. So choose the state of nature with the highest probability, and among the alternative with the bull market, you choose the maximum payout. Okay, that is the maximum likelihood criteria. And of course, this case you choose stock A. And there is the last thing for this, and this I tell you, the second way, maximum likelihood criterion, is for people like probability. Okay, people like to probability. But here, actually, this for people like probability, theory of probability, expected value criterion. In order to I don't know. I don't know which one. I don't base on the belief, my belief or something. I base on the mathematics. I base on tool mathematics as a tool. And you study probability, you know, in the theory of probability there is expected value. Expected value means average value. So we calculate average value of A and average value of B. And which one is bigger? I choose that one. That's all. Easy. So expected value criterion is the most commonly chosen criterion for decision making under risk. We are in the situation under risk, and it is a commonly chosen criterion. This is commonly chosen. That means that this is the criterion that people prefer. Many people prefer this way. And what is it? By this criterion, decision alternatives are compared based on the maximization expected payout. We calculate the expected value, expectation of all the alternative A, B, stock A, stock B, or something like this. And then which one have the higher expectation? You choose the alternative with the maximum expected payout. And how to calculate the expected payout, for example, in this case, in this table, how can we calculate the expected payout? I delete some things here, and then you can see. Expected payout of A is what? It's equal to the payout here. The payout here multiplied by this. Multiplied by the expected payout, like expected expectation. You calculate the expectation of the discrete random variable. Okay, so this number multiplied by 0.6 plus this multiplied by 0.4, and you calculate, and then it equals something here. And the expected value of the company B, 1000 15 multiplied by 0.6, and then plus 500 multiplied by 0.4, then that's equal to some number here. So the expected, this is the expected value of B, and this is the expected value of A, and we calculate, and we have what? 5,000 multiplied by 0.6 plus 1,000. No, sorry. Terrible. 5,000 multiplied by 0.6 minus 2,000 multiplied by 0.4. That is equal to 2,900. This number is 2,900. 2,900. And the second one, 1,500. You calculate parallelly with me. You see that if I make the calculation is correct or not. 1,500 multiplied by 0.6 plus 500 multiplied by 0.4, and that is equal 1,100. So you see, if you calculate this way, you take the expectation in this way, and you see the expectation of company A is 2,900, and the company B is 1,100. So which one is bigger? A is bigger. Okay, this is the maximum, and so if you love this way, if you love expectation, you love probability theory, you should choose this way. And many people like this way. Is that okay? It's good. It's a good way. So this way is called the expected value criterion. Is that okay? And the expected value of A is this, of B is this. So it's it. Oh my God. So my calculation is not correct. 2,200. Let me 5,000 multiplied by 0.6 minus 2,000 multiplied by 0.4 equal. Okay, 2,200. So my 2,200. Sorry. My calculation is not correct. 2,200. Okay. And expected value. So decision making without experimentation, but we want to consider the general situation. The general situation like this. Here, what we call the state of nature. State of nature, you have a state of nature 1, 2, 3, state of nature n. You have n state of nature. In the example there, we have a 2 state of nature, bull, bear. Is that okay? But in the general case, we have n state of nature, and we have the alternative. The alternative, the alternative we should choose. We should choose one, only one. But among the m, you have m alternative, A1, A2, AM. So with the given here is a payoff. This is payoff. Payoff. Like 5,000 minus 2,000, 1,500, 500, something in our example. And here is the probability of the occurrence. Probability of occurrence of what? Occurrence means what? Occurrence of state of nature. State of nature 1, the probability is P1. The probability of occurrence nature state of nature 2 is P2. And so you see that there is two, in our case, we have a 2 state of nature, bull or bear. One is 60%, another one is 40%. So that means the sum is 100%. Okay? And here you have n segment nature, Sn1, Sn2, Sn. So you have the probability for each of them is P1, P2, Pn. And so the sum of them must be 1. So you must have something like P1. So P1, let me write down in red so it's easy to see. P1 plus P2 plus P3 plus Pn is 1. 1 means 100%. See? 100%. So be like this. And then and then if you have this table, so how can you calculate the expected value? The expected value is of A1 here. So you look at the first row. Expected value of A1 is equal to what? P1 multiplied by A1, P2 multiplied by A12, P3 here multiplied by A13 here. And then like this, here. A11 P1, A12 P2, A13 P3, and plus A1J Pj, and the last one, A1N Pn. Sum of all this one, and then you have EV1. And by that way, you have EV2. That means the expectation of A2, A3, and you compare all of them, all of the expectation, AV1, AV2, AVM. The biggest one, the maximum of this is the thing that you should choose. Okay? Here. The best alternative VI0 here. The best alternative is the one which here is the maximum of this. And in this case, you choose what? You choose AI0. The alternative we should choose is AI0. The biggest expectation among the alternative. Okay. Now we have about 15 minutes. So we should come to the next one. Is that okay? So at least we come to the situation for you to look back at the Bayes theorem at home. And so the next week we can continue with easier. Decision making with experimentation. Okay. We continue. We continue the example there. The bull market, bear market, stock A, stock B is okay. Continue. The expect in the previous subsection 3.1, now is 3.2. You remember? Now is with experiment. That the expected value criterion, also other criterions. I may make a mistake. You just wait a minute. I think I make a mistake here with the English. Yeah, exactly my mistake. Do you find out something wrong here? You get 5 points if you find out in the first from here to here. Relies solely on the probability available from historical data, called prior probability. Just only in this paragraph. This is only actually only one sentence. There's something wrong here. Five points. See something wrong? English. Only English. So I give a hint. You know what does it mean, data? Data means what? Data in Vietnamese mean something like this. Is that okay? Like this. But data is come from datum. This is single. This is a plural. Plural. One datum, but two data. See? Normally you have one table, two tables with the S. But now, one datum, two data. You know this? Hello? Nguyễn Anh Khôi, you know this?
Dạ thưa cha.
You know any words what's have something similar like this?
No thưa cha.
You study analysis 1 already, is that right? Of course, I think so. Analysis 1, analysis 2. So you have maximum. 1 maximum, but 2. Then is what? Maximum. Minimum. Then minima. You know this? Plural. Minimum, minima. Maximum, maxima. Datum, data. But here I make a wrong thing. Criterion, okay. Criterion is okay. Criterion is okay. But the plural of criterion is not criterions. No. Criterion. And plural will be, you know, criteria. So here is criteria. It's my mistake. Datum, you should remember. There's some the words in Latin. So it's always like this. Then plural will become a. Datum, data, criterion, criteria, maximum, maxima, extremum, extrema. It's just for fun, but you should know that. Okay, of course, I tell you this because I think that you learn analysis 1 already, maximum, minimum of function, and then there will be maxima, minima, extrema. Okay. Okay. And so continue. We continue. So here criteria. In the previous section 3.1, the expected value criterion, also other criteria, relies solely on the probability available from historical data. We call it the prior probability. Prior probability. That means historical data. So what does it mean? You look at the example again. Here. You look at this example again, you will see that probability of occurrence here, the probability here, we call prior probability. The probability was taken from the experience in the past or something like this. Is that okay? Not the data. So now we call prior probability. But what we want to do now is we want to make some more experiments. With experiments. So now what we want now is this come from the old. Is that okay? And may not be exact, something reliable or something like this. And so it's natural. It is natural to think of doing some more experimentation to improve the preliminary estimate, to improve the estimation from the prior probability. Improve this. Is that okay? To make it better. Because this comes from the old things, from the experience of people or something like this. Now we want to make some more. The key point here is we want to make some more experimentation and to improve the preliminary estimate. That means the prior prior probability. Improve that one. That okay? So if, for example, if for this table, but you can improve this one, you can improve this one for so that it's close to the real thing, and then your calculation is more exact, and my calculation, your calculation is more exact. So it means that our decision will be more good, more better, will be better. Okay, the estimation here is better. Our decision is better. Okay, the expectation we calculate is closer and closer to the real things, and then our decision based on this will be better. And that's the idea. And the question is, how can we improve this prior probability? And the way we do is this. Here. We come back to the example one. We say example one revisited. Suppose that Jack does not rely solely on the probability of the moon is 60% and the bear is 40%. On the financial publication. Of course, in financial publication on some concerned, that is public. Everybody knows this, okay? And it comes from some calculation based on the data from the past, something like this. So, what he do? He wants to conduct a personal investigation by consulting an expert in stock market. You know, if you really want to invest in stock, the investigation should be more. Investigation should be needed. You make more and more investigation. You get more and more exact data, and then your calculation is more and more close to the real fact. And that means that your definition is better. Your definition is better means you rarely you will lose the money. Okay, often you got. So the investigation, the experiment we call experiments that check we do is it. We ask we consent personal investigation by consulting an expert of the stock market. That means that in this case, we don't say anything. But if you want to want them, the expert in stock market, if you want them to do something more, you have to pay money for them. Okay, it's just little money. But here we don't care about this. An expert offer general opinion for or against the investment. He just say for or against. That's all. Your investment. So the expert's opinions is further quantified in the following manner. He gave some advice in this way. If the market is bull, there is 90% chance to vote for. And if the market is bear, the chance for of a vote for is only 50%. So here it is quite hard for people who have not yet studied the cost of probability. I don't know how can you should read something more. By the way, I have something. Just a moment. I have this. Yes, last semester I did this course, mathematics for biotech, biotechnology, and there is a course. that there is a chapter introduction to probability. So now, if you have not yet studied the course of probability with Dr. Kwon, and then you can read this one. Here, the first part is including all the things that you need for the section 3.2 of decision making. You have a basic concept of probability, conditional probability, independent events, and the Bayes theorem. So this is enough for us to study the decision making under risk, but the second part with experiment here. And then I will upload this. I will upload this part of my lecture notes to the Blackboard. Is that okay? Any of you who have not yet studied the probability, you can download and take a look. Okay. Oh my God, where is it? Okay. So here, continue. What time now? It's okay. So I will tell you 5 minutes more. Here. So how to make use of additional information? The additional information that the experts give you like this. He just say, if the market is bull, there is 90% chance for fall. But if the market is bear, that's 50% for fall. Fall, that means agree with your investigation and your invention. What's your investment? Okay. Oh, sorry. Here, if the expert's recommendation is 4, then Woodcheck will invest or A or B. And if his recommendation, he just say 4 or against. If he say against, then what stock he should invest? So if we write out a bit more clearly, and then you will see findings after experimentation. If we call new 1 is the event 4, new 2 is against. The state of nature is M1 is bull, M2 is bear. And so if the bull market, so that means if the condition here, if the bull market, so it means that the condition is the bull market here. And then 90% chance for 4. So 4 is new 1. So 4 P of 4, probability of 4 under the situation is bull is 90%. So the sentence here, so means is P, and so what does it mean? It means that in the case the market is bull, and then the against is what? 4 is 90%, so again is 10% here. Okay. And what he say, the second say, bear market, if the market is bear, the condition is bear here, M2 over M2, and then the vote for is 50%, and then the vote again is also 50%. Is that okay? But what we need is what? What we need here is here. You remember? We want to improve this. We want to improve these two numbers. We want to improve these two numbers here. But what is it? This is the probability of the bull market, the probability of the bear market. And so what we want is this. What we want is actually this. Here. If he say 4, if he say 4, is that okay? Then what is the A is the probability of bull. What is the probability of the bull market? What is the probability of bear market? Is that okay? So if he say 4, then what is the probability bull over their condition is 4. Under, if he say 4, so what is the probability of bull? What is the probability of bear? If you know probability of bull, probability of bear, then you can find out, you can calculate the expectation. Is that okay? You can find out the expectation. So what did they, you know is it, if it's bull, then this one is 0.9. Is that okay? And now what you want to find out is what? The converse. P of M1, for example, over new one. If he call 4, then what is it? If he call 4, then what is it? P, we need to have P over 4, like this, bull market. And P, if he say 4, and then bear market, we calculate this one. When calculate this one, and then we can use this number to calculate the expectation. Is that okay? And you know, in the theory of probability, if you have something like this, P A over B, and now you want to find out P B over A, then you do what? No, that is no. You know this one, and you want to find out this, then there is one formula for this, is Bayes theorem. Is that right? Quang Khai? Hello? Hello, Quang Khai?
Oh, yes. Yeah, hello.
You know this. If you know PA over B, if you want to find out PB over A, you need the Bayes theorem. And that's the reason why I tell you that you need to read back just only one part about the Bayes theorem. And here in this, what I'm writing down here, things here is just the way how to use the Bayes theorem. And they use the Bayes theorem, and then they calculate here, this. And then, for example, if the experts say 4, so that means we delete this one. And so we have this table, and we can find out the expectation of A and B. Expectation of A, this multiplied by this multiplied by this, and then plus, then you have expectation of A. And by the same way, you have expectation of B, and you can compare. And in this case, the expectation, the probability here is improved. The last time you see that the probability is 60%, but now after make more inspection, we will see that the new calculation is 73%. It's a bit higher, and this is more exact than the other one. Okay, so time is over, and we stop now, and see you next week. And I hope that you will take a look back at the Bayes theorem. Okay, next week we finish this one, and then we study the last part of this chapter. That's decision making under uncertainty. Okay, bye bye.
Yes, bye, teacher.
Okay.
Goodbye, sir.
Okay, bye bye. See you next week.
Goodbye